Alright, so first thing I'm going to do is explain how momentum, heat, and mass transfer are all related by their specific gradients and diffusivity, and how diffusivity is in meters per second squared. First, let's start with the universal transfer equation, which is flux is equal to negative diffusivity times the specific concentration gradient. So I'll show the first example is mass transfer, which is also known as Fick's law, which is molar flux, which is in moles per meter squared per second, which is equal to negative molar diffusivity, which is in meters squared per second, times molar concentration, which is in moles meters cubed per meter. The second one that I'm going to go over is momentum transfer, which is also known as Newton's law of viscosity, which is shear stress, which is kilogram per meters squared per second, which is equal to negative kinematic viscosity, which is in meters cubed per second, times the gradient of mass per volume, which is kilogram per meters cubed. And then heat transfer, which is known as Fourier's law, that equation is heat flux, which is in joules per meters per second squared, which is equal to negative thermal diffusivity, which is meters squared per second, times the gradient of internal energy per volume, which is Cp times dx, which units are joules per meter cube. All of these are related by their specific concentrations and negative diffusivity at meters squared per second. Now, I am going to explain why there is a negative sign and the difference between thermal conductivity and thermal diffusivity. The reason why there is a negative sign in front of diffusivity is when you think of a temperature gradient, as temperature increases over a distance, it increases, and heat flows in opposite direction. Meaning, diffusivity would go in the opposite direction of the gradient. So that's why there is a negative sign. So now, the difference between thermal conductivity and thermal diffusivity. First being, thermal conductivity is the ability to conduct heat. And thermal diffusivity is the ability to the ability to diffuse heat, or not necessarily heat, but I guess diffuse temperature. The second being, conductivity is a property of the said material. Like metals being able to transfer heat way easier than plastics, and plastics used as insulation, the ability to conduct heat. Diffusivity is property being able to be calculated, and you can calculate it by the conductivity divided by the density times the heat capacity. So there we go.